Hello and welcome to this video on solving quadratic equations using the zero product property. Or you could say solving quadratic equations by factoring. And I'll just do several examples and going through the procedure each time, and hopefully we'll see how that's done. Alright. So I'll start here with this example where I'm asked to use the zero product property, which I'll be abbreviating ZPP, to solve the following equation. Okay. Well, first let me state what the zero product property is. That it is if we have a product, right, some multiplication, A times B times C times whatever. I'll just stick with A times B here, a couple factors. If we have a product that is equivalent to 0, then we can say something about one of these two factors, if not both of them. Right? Because the only way a product is going to be equal to 0 is if either A, the factor A is 0, or the other factor is 0, or both. Right? They both could be 0, but this is the key right here. We're going to take a product that's equal to 0 and say, hey, one of these factors has to be 0. So basically taking one equation and kind of splitting it up into two possible equations. So in this first example here, see I have a product on the left side of the equal sign, x times the quantity x plus 3 equal to 0. So I can apply, because it's equal to a product equal to 0, I can apply this zero product property and say that the only way this is going to happen, according to this zero product property, either one factor is 0, so this x could be 0, or the other factor could be 0, the x plus 3 could be 0, and this would still be a true statement. And then we solve each of these. So either x equals 0, or, and then in this equation here, x plus 3 equals 0, subtract 3 from both sides, the value of x could be negative 3. Alright, and then we, of course, with any equation, now you could do this mentally, but for this first couple of examples, I'll actually check. When x equals 0, I replace x with 0. You'd have 0 for the first factor, times, and then 0 plus 3 for the second factor. Is that equal to 0? Well, let's see. This is 0 times 3 equals 0, or 0 equals 0, right? Anything times 0 is 0. So yes, this is a true statement. So the value of x being 0 is a solution of this equation. And now let me check the other one. So I replace all the x's in the equation with negative 3. So the first factor, which is just x, becomes negative 3 times, and then the second factor, you got negative 3 replacing the x plus 3, and is this product equal to 0? Well, this would be negative 3 times, and then the second factor, negative 3 plus 3 is 0. And is that equal to 0? Yes, you have 0 equals 0 again. So yes, so both of these, 0 can replace x and make that true. Negative 3 can replace the x's and make that true. So both of these numbers are solutions to this equation. And in fact, we might write it out this way, that the solution set of the equation is the set of numbers 0 and negative 3. right, and close the braces and all that. But just a little list of all the numbers I can replace the variable with and make a true statement. All right, so you might see some texts, some books express the solutions this way as a set of numbers that make the statement true. Wonderful. All right, so here's one other example where I'm using the zero product property straight away. You see I have a product over here with two factors, x minus 2 times 4x plus 5, and it is a product equal to 0. All right, if this was some other number over here, I couldn't use the zero product property, right? It's got to be a product equal to 0 only. It's the only time we can then say one of the factors has to be 0. So I can apply the zero product property, right, by the ZPP, zero product property. Either this factor is 0, right? If this factor was 0, the whole thing would be true. Or if this factor were 0, the whole thing would be true, right? 4x plus 5. All right, and then we solve these. So the first one, I would just simply add 2 to both sides, right? A little plus 2 there this time. So the value of x could be replaced with 0 plus 2, positive 2. Or, and then this side I would subtract 5 first. Then we have 4x equals negative 5, and then divide by 4. Or x could be replaced by negative 5/4. Right? And then we check. Now, hopefully it's obvious that they'll work. But if I take this off to the side here, let's check these. And again, I'm just going to do this for the first couple examples. I do have a bunch today. When x is 2, the first factor becomes 2 minus 2 times, and then 4 times 2 plus 5 for the second factor, replacing x with 2. Is that equal to 0? Well, 2 minus 2 is 0, so I have a factor of 0 times, and then 4 times 2 plus 5 is 13, 8 plus 5. And 0 times 13 is 0, right? You get 0 equals 0, that is true. Okay, so 2 is a good solution. Okay. And then let's check negative 5/4. Alright, moving on to this one. So the first factor, you have negative 5/4 replacing x, and then minus 2. The second factor, times, and then 4 times negative 5/4 plus 5. And is this equal to 0? Right. The first factor, remember, when you add or subtract, you need a common denominator. So remember 2 here, this would be like 8 over 4, right? This is 2 over 1 right now. So negative 5/4 minus 8/4, this first factor would be negative 13 over 4. Right? And when you get a common denominator, right, that denominator stays the same, you just combine the numerators. And then here, the 4's cancel, you have negative 5 plus 5, that's 0. And as we already know, anything times 0 is 0, so we still get 0 equals 0. Yes, all right, negative 5/4 does in fact work, is a solution. So again, the solution set for this equation is the set, indicated by these braces here, with just the number 2 and the number negative 5/4, and that's it. There's the set of all the solutions, all the numbers that I can replace x with and get a true statement in my original equation. Great. Well, so these past two examples were set up so that I could use the zero product property straight away. Right? It was already in the form of a product equal to 0. But that's not always the case with some of these quadratic equations, degree 2 equations. Sometimes we have to get it there by factoring. Alright, so to see the rest of my examples, I'm going to be asked to solve each equation by factoring. Alright. So I'll write out the steps in this first example as we go through it. So the first one, and this is for quadratics, when the highest power on the variable is going to be 2. The first step is going to be write in what's called standard form for a polynomial equation. Now standard form for a polynomial equation is simply get a polynomial on one side. And in this case we're talking about quadratics, right? So the highest is degree 2. Get a polynomial on one side completely multiplied out. Notice no parentheses, everything's written out term by term, and 0 on the other side of the equal sign. So the standard form for a quadratic equation would be a times the variable squared plus b times the variable to the first plus c equals 0, where a, b, and c are just numbers, just real numbers. So that's already done here. Alright, so this example I'm looking at with the p squared minus 6p plus 8 equals 0 is already in this standard form where a is 1, b is negative 6, and c is positive 8. Then, after you have it in this standard form with 0 on the other side, polynomial on one side, factor. Alright, so I've put up videos in the past on factoring polynomials, factoring quadratics of this form. So you can look those up. I'm gonna do a little faster here in this video, or you could look up other videos or read your book. But factor the polynomial completely. So we're going to rewrite this ax squared plus bx plus c as a product. Alright, and then we'll use the zero product property. But for right now, let's do part 2. So here, p squared minus 6p plus 8. Remember how I do this? I take the a times c is 1 times 8. That's just 8. And then I think of what are a pair of factors of 8, positive 8, that add up to negative 6. And that would be negative 4 and negative 2. Right? Those multiply to be positive 8 and add to be negative 6. And since the lead coefficient is 1, right, it's 1p squared, this factors pretty quickly. I can jump now. I know the factors are going to be p plus negative 4 or p minus 4 times, and then p plus the other one plus negative 2, or p minus 2. Okay, so I've done step 2. Right, first step, standard form. Step 2, factor the polynomial completely. And now I have what I had in the first 2 examples from this video. We have a product of multiple 2 factors here equal to 0. So that's step 3. Apply the zero product property, and of course check your solutions. But this time I'm going to check mentally. Alright, I'll just kind of speak them out. Alright, so here by the zero product property, right, I've got a product equal to 0, so I can apply the by the zero product property. Either this factor p minus 4 equals 0, or this factor p minus 2 equals 0. And then we solve each of these. Right here I'm just adding 4, so either p equals positive 4, or here I'm just adding 2 to both sides, p equals positive 2. And then we check these. Okay, now I'm going to again check them back in the original equation. So when p is 4 squared is 16. 6 times 4, right, replacing p with 4, is 24. 16 minus 24 would be negative 8, and then plus 8 would be 0. So 4 is a good solution. Right, so I'll put that in a box. And then I check 2. So you see 2 squared is 4. 6 times 2 is 12. 4 minus 12 is negative 8 again, plus 8 is 0. 2 also works. Alright, so when I'm done here, the solution set it should be 2 words, solution set, is the set of numbers 4 and 2. Alright, those are the only 2 numbers that satisfy this equation when you replace it with p. Right? P with 4 and p with 2. Great, but these steps here are going to be the same steps I'm going to follow in all my examples, and I do have several more. Okay, so the next example, another quadratic equation, this time in the variable t, say pi is powers 2. The first step is to get it in that standard form. A times t squared plus b times t equals 0. Well, I do not have that yet, right? This is equals 3. So the first thing I'm going to do here is subtract 3. Get everything to one side, 0 on the other. So now we have 2t squared, then the minus 5t, and then minus 3. Right? I subtracted 3 from both sides, equals 0. Okay. Now it's in standard form, and then we factor. All right. So remember, I would take 2 times negative 3. A times c is negative 6. Then looking for a pair of factors of negative 6 that add up to negative 5. That would be negative 6 and positive 1. And then I could factor by grouping. All right, and I'll demonstrate that one time here for this one example, where I use this number, because the lead coefficient is not 1. So it's not just going to be t minus 6 times t plus 1. The lead coefficient is not 1. So I'm going to do this thing with grouping where I put 2t squared, and then I'm going to rewrite negative 5t as negative 6t plus t. So negative 6t can go in the first grouping, then a big plus sign, and then 1t can go in the second grouping, negative 6t and then 1t. That makes negative 5t. And then the minus 3, the last term in the second grouping. And this is still equal to 0, and I got equal 0 there. You factor each half, right? Factor each group. This group here, the greatest common factor would be 2t. And if I remove 2t from this first group, I have t minus 3 left over. And this group here, the greatest common factor is 1. So if you'd like, write 1. I pull out a 1, and what's left over is still just t minus 3. And then the whole thing now, both of these products have a common factor of t minus 3. So t minus 3 comes out, times, and then what's left over when I remove the t minus 3's is 2t plus 1. Right, and you can double check by multiplying, right? Multiply t minus 3 and 2t plus 1 by foiling. You're going to get 2t squared minus 5t minus 3 back. Alright, so I've put it in standard form, factored that polynomial completely, and now I have a product equal to 0, which is exactly what I want. I'm going to apply that 0 product property, right? By the 0 product property, either t minus 3, this factor, is equal to 0, or 2t plus 1 is equal to 0. And we solve each of these. So here I'm just simply adding 3. So either t equals 3, or, and then this one would be 2 steps. I'd subtract 1, get negative 1 over here, and then divide by 2. We'd have t equals negative 1/2, or negative 0.5. And check them. And I'll promise you right now, there's nothing up here that would make me divide by 0, right? There's no denominators with variables. So if you do everything correctly for these quadratics, you should be good. I still check them, but I promise you they're going to work. All right, check them on your own. All right, so the solution set for this equation is the set of numbers with 3 in it and negative 1/2, right? So these two numbers can replace the letter t and make the equation a true statement. You would get 3 equals 3 back in the beginning. Wonderful. Now let's try that again. Again, a bunch of examples. So here's another one. Again, it's not in that standard form. All right, standard form is that ax squared plus bx plus c equals 0, not equals 5. So I take everything to one side again. So I'm going to subtract, get rid of the 5, make that a 0. So now I have 2x squared plus 3x and minus 5 equals 0. Okay, it's in that ax squared plus bx plus c equals 0 form, now standard form. Then I factor. Now, I did the grouping in the last example. I'm just going to jump to what the factors are going to be here. I know I'm going to need a 2x in one of these and a 1x in the other to make the 2x squared in the beginning. And then I need factors of negative 5 in these other two spaces so that I end up with the positive 3x after I FOIL. So I would need plus 5 here and minus 1 here, and let's double check that. 2x times x, 2x squared, then minus 2x plus 5x would be plus 3x, and then you got minus 5, right? So this factors completely to 2x plus 5 times x minus 1, and then we can apply now the zero product property, right? I've got a product of two factors here equal to 0. Right? It's got to be equal 0 to apply this. So by the zero product property, either 2x plus 5 is equal to 0, or the other factor, x minus 1, is equal to 0. And then we solve these, right? So either x is, subtract 5, divide by 2. So x is either negative 5 halves, negative 2.5, or here add 1, or x equals 1. All right, and I'll just check them on your own. I promise you that they're going to work this time, right? Again, there's no way I'm like dividing by 0 or anything, but put these back in for x in the original equation. Yeah, it's easy to see with 1, right? When x is 1, you're just getting 2 plus 3 equals 5. That works. Negative 5 halves you might want to check on your own, but they do. All right, so I'm not going to write the solution set this time, right? The solution set has the numbers negative 5 halves and positive 1. Great. Here's yet another one where I'm, notice it's now in z, right, the variable z, but it's not in standard form. So I get it in that standard form. A times z squared plus b times z plus c equals 0. And that would just require the adding of 9z to both sides, right? Make that a 0. Do the same thing over here. And again, I'm putting things in order of the power on z. So z squared first, then 9z, then 20. Okay, so you have z squared plus 9z, then plus 20. Right there, and then equals 0. Standard form. All right, again, a times z squared plus b times z plus c equals 0. So I'm in standard form. I factor now this polynomial, which would factor to z plus 4 times z plus 5. Again, I'm going to kind of rush through the factoring here. I've made several videos on factoring before and demonstrated a little bit earlier in the video, so we'll rush through the factoring a bit. And you can double check. If I multiply z plus 4 times z plus 5, I'm going to get z squared plus 9z plus 20 back. And now I have what I want. I have a product multiplication here equal to 0. So again, by this I can apply this zero product property, say that, well, if this is the case, then either z plus 4 is 0, right, this factor, or the other factor, z plus 5, is 0. And then we solve each of these, so we're getting z equals either negative 4 or z equals negative 5, and you can check them both, and you can see that they'll both work. All right, I'll do negative 4 very quickly. If I put negative 4 in for z, that'd be 16, right? Negative 4 times negative 4 squared. 16 plus 20 is 36. And then negative 9 times negative 4 is positive 36 again. You get 36 equals 36. That works. Negative 5 also. Check it out. Here's another one with the variable k. This one will involve a little more movement in the beginning. But again, not in standard form. I want a times k squared plus b times k plus c equals 0. Everything on one side, 0 on the other. So I think it'll be easier to move these two terms, right? So I'm going to take away 3 from both sides, which will go with that negative 1. And then I'm going to add 5k, right? And that would go with this 3k over here, right? Combine like terms. So I've got 5k squared, then plus 8k, and then negative 1 plus negative 3 is negative 4, and it's equal to 0. Okay, and then we factor this. Again, I'm going to kind of skip to the end. You can do the whole grouping thing if you want, or trial and error. But there's got to be a 5k in one of them, a 1k in the other one, and then I'm looking to make positive 8k. So like I need a plus 2 over here and a minus 2 over here, right? That way I get 10k minus 2k, right, to positive 8k, and then negative 2 times positive 2 is negative 4. Okay, and again, double check, multiply these, you'll get 5k squared plus 8k minus 4 back. And now I have what I want, a product equal to 0. And if that's the case, I apply that 0 product property. According to that, if a product is equal to 0, then either the one factor is equal to 0, either 5k minus 2 is equal to 0, or the other factor, k plus 2, is equal to 0. And we see what happen. When is that going to happen, right? So this is happening. 5k minus 2 will be 0 when k is positive 2/5, right? I would add 2 divided by 5. Or the other factor, k plus 2, would be 0 when k is negative 2. And then we check these, check these back in the original equation. And I'll do negative 2 really quick. Negative 2 squared is 4. 5 times 4 is 20. 3 times negative 2 is negative 6. So I have 20 minus 6 minus 1. That'd be 20 minus 7. That'd be 13 on this side, right? So 13 on the left. And then when k is negative 2, negative 5 times negative 2 is 10 plus 3 is 13. You get 13 equals 13. This works, and I leave it to you to check that 2/5 works as well, but it will. All right. There's nothing, nowhere where I'd be dividing by 0 up here. Great, so there's the two numbers in the solution set for that equation. Okay. Here's yet another example. All right, 3x squared plus 9x equals 4 minus 2x. Again, first thing I want to do when asked to solve by factoring is get it in that standard form. Everything on one side, 0 on the other. So I'll keep the square where it is, and let's take away the stuff from the right side. I'll subtract the 4, which won't go with anything over here. There's no just constants over here. And then I'll add the 2x, right? Get rid of the negative 2x. That'll go, add the 2x here, that'll go with the 9x, right? They're like terms. So I have on the left side 3x squared, and then the positive 2x plus the positive 9x, positive 11x, and then the minus 4 wouldn't go with anything, so minus 4. And over here you got nothing, right? Equals 0, and this is what I want. ax squared plus bx plus c equals 0. Alright, and then now that it's in standard form, I factor. Again, I'm going to kind of skip to the end. We'll just look at what it's going to be when you factor it. I need a 3x in one and x in the other. And I need factors of negative 4 here and here, so that I get an 11x when I FOIL. So positive 4 needs to be here, negative 1 needs to be here, right? Because you see that would give me 12x when I multiply the 3x and the 4, and then minus 1x when I multiply these two, and 12x minus 1x is 11x. And then again, multiply these together, you'll get 3x squared plus 11x minus 4. And now I have what I want, a product equal to 0. So I can apply that 0 product property. And by the 0 product property, if a product equals 0, then either one of the factors has to be 0. So either 3x minus 1 is 0, or the other factor, x plus 4. has to be 0, and then we try solving these, right? The only way this is happening is if x is positive 1/3, right? I would add 1 divided by 3. Or, in this scenario, x would have to be -4. And then check them. And again, I'll let you know right now that they're both going to work. All right. Check them out, though, on your own. You should anyway for any equation. Okay, so 1/3 and -4 for that one. All right, now I'm getting into some problems where a common mistake occurs. All right, so here's one. Has to solve this equation by factoring. X minus 3 times x plus 5 equals 9. Notice that this number here is not 0. All right, it is 9. So that means I can't use the zero product property. Right? Very often I see people make this mistake where they'll, oh, I've got a product over here. And I remember seeing some stuff where if I have a product on one side, I can just split it up, and they'll say, oh, let x minus 3 be 9, and then let x plus 5 be 9. And so here's a mistake. All right? So I let x minus 3 say, well, x minus 3 could be 9, and then x would be 12, and then x plus 5, let that be 9, and then x would be 4. But if you check these, all right, look at what happens when you check these, though. If x were 12, you'd have 12 minus 3, 9, times 12 plus 5. You'd have 9 times 17 is 9. That is no good. And the same thing for 4. Well, okay. Not the same thing for 4. You'd actually get very lucky with this example, but just know that it won't always work. There's a when x is 4, you get 9 here, you get 1 there. 1 times 9 is 9. This actually works, but this whole process I did over here was a mistake. You can't just split that up because again, you're getting incorrect solutions like 12. All right, and it doesn't always. You won't always luck out and get one like 4. Right? You won't get. Not always going to work. Because if two numbers multiply to be 9, that doesn't mean one of those factors has to be 9, which is what this is saying over here. You could have 18 and a half, right? 18 times a half, or 27 times a third, or whatever. 9 times 1, sure, but there's lots of other possibilities. The only way we can split it up is if the number on the other side is 0. Okay, so as with the previous examples, I want to get this in standard form first. The ax squared plus bx plus c equals 0. And in order to do that, I need to get rid of the parentheses. So that means I need to multiply this side out. X minus 3 times x plus 5, you distribute the x, distribute the negative 3. That would be x squared plus 2x minus 15 equals 9. Right? And now the parentheses are gone, great, but I still want to get it in that standard form, right, where everything's on one side, zero's on the other. So I subtract 9, and now I have x squared plus 2x, then minus 24, right, negative 15 plus 9 equals 0. And now I have it in standard form, right, and we factor. This x squared plus 2x minus 24, that would factor to x plus 6 times x minus 4, and equal, now we have what we want. We have a product equal to 0. And I can apply the zero product property. So either x plus 6 equals 0, or x minus 4 equals 0. And we solve each of these. X equals negative 6, or x equals 4. And check them. Now I know I already checked 4, back in the mistake part. Right, again, this is not good. We lucked out getting 4 here, but see, 4 is a solution, right? You'd have 1 times 9 equals 9. But negative 6, right? This one I didn't get earlier, right? When I made that error. Negative 6 is good, right? You'd get negative 9 times negative 1. That would be positive 9, so that's good as well. So yeah, be careful. When a product is equal to some number other than 0, you can't do the splitting up like we do when we use the zero product property. So here I have another one where that same point is going to be made. See, it's like, oh, I've got a product. oh man, I've got a product, I can just split them up. Say x plus 3 equals this, and 2x minus 1 equals this, and then you end up with incorrect stuff. You might get lucky and get one of the solutions, but chances are you're not. You're going to miss out. So same thing, I'm asked to solve this. It's going to be a quadratic. The highest power on the x will be 2. I'm going to solve this by factoring. I need to get it in that standard form first, that ax squared plus bx plus c equals 0. No parentheses, so I want to multiply these two first. Now if I multiply these two, I'd have 2x squared, and then minus x plus 6x, so plus 5x, and then minus 3 equals 7x minus 3x squared. And then I'll take everything to one side. Now I personally like having a positive lead coefficient, so a positive number on my x squared. So if I say I subtracted 2x squared, that would give me negative 5x squared over here. I don't want that. So I'm going to take everything to the left. I'm going to add the 3x squared. That'll get rid of this, and then I'll add the 3x squared to this side as well, right? See, that'll give me a positive 5x squared. I like having a positive number as the lead coefficient. And then get rid of the 7x, so 7x minus 7x, and then I'll subtract 7x from over here as well. Alright, so now I have 5x squared minus 2x when I combine those, and then minus 3 equals 0. And this is what we want. ax squared plus bx plus c equals 0. Standard form for a quadratic equation. Then factor, if you can, right? I would need a 5x in one of these and x in the other. And I would like to have it so that we get negative 2x after foiling. So I'd have to have minus 3 here, or plus 3 here, minus 1 there, right? To give me minus 5x plus 3x, the minus 2x. Okay, and multiply this out, you'll get this back. 5x squared minus 2x minus 3. Alright, and then we have this product equal to 0. So I can apply the zero product property. And by the zero product property, either 5x plus 3 is equal to 0, or this other factor of x minus 1 is equal to 0. And then solving, you get x equals negative 3/5, or x could also be 1, right? And check them. I promise you they both work. Check them back in the original equation. Plugging in 1 would be quick. I'll do the 1. If I plug in 1 for x, you'd have 4 times 1, so you have 4 on the left equals 7 minus 3, right? 4 on the right. 4 equals 4. 1 works. And do it on your own with negative 3/5. All right. So another one. Why not? All right. So 9p squared plus 16 equals 24p. Again, I want standard form. So I'm going to take away the 24p, right? Get everything to one side. Get ap squared plus bp plus c equals 0. So 9p squared minus 24p plus 16 equals 0. And then this one here, 9p squared minus 24p plus 16, I've put out in other videos. This is one of those perfect square trinomials, meaning it has the same factor twice. If you were to factor this would be 3p minus 4 times 3p minus 4 again. Right? So they might write that as this, the quantity 3p minus 4 squared. And you can double check. Take 3p minus 4 times 3p minus 4 and do all the foiling. You get 9p squared minus 24p equals plus 16. And then this is equal to 0. Now you might be saying, hey, where's the product? Well, remember, when you raise something to a power, this is a product. This is 3p minus 4 times 3p minus 4. So the only way that this is going to happen, right, when I apply the zero product property here, well, there's only one factor over here. It's the same factor twice. So the only way this is going to be true is when 3p minus 4 equals 0. Right? Because only 0 squared is 0. Nothing else squared will give you 0. And so the only solution here is positive 4/3, right? P equals 4/3. And that's it. Now, in most texts, you'll see that because there were two of these, All right, there were two of the 3p minus 4s, 3p minus 4 squared. You might call this 4/3 here a double root or a double solution. Root, just a fancy word, another word for a solution to an equation. And this is sometimes referred to as a double root or a double solution because there were two factors that this number would make 0. All right. And if there are more, they'll just call it a repeated root or a repeated solution because there was more than one factor that number made 0. So I believe I have another example where we end up with a double root. Let's see. So here I have x squared plus 11x plus 24 equals x minus 1. Again, standard form. Take away x from both sides and then add 1 to both sides. And I have x squared and then plus 10x and then plus 25 equals 0, right? Standard form. This is another one of those perfect square trinomials. It factors to the same factor twice, and that would be x plus 5 times x plus 5. And you can double check that, multiply that out. Take x plus 5 times x plus 5 and FOIL, you get x squared plus 10x plus 25. So by this, now I have what I want, a product, x plus 5 times x plus 5 equals 0. So I can apply the zero product property. Well, since it's the same factor again, the only way this is going to happen is if x plus 5, the factor of x plus 5 is equal to 0. And then I solve. So x equals -5 is the solution to this equation. And again, they would call this, because there were two of those factors that -5 would make 0, there was x plus 5 and x plus 5, or x plus 5 squared, this would be called a double root or a double solution, right? Because there were two factors that would make 0. All right, and then my last couple examples, just again to remind you how to factor. I've been talking about factoring. Here's another quadratic, 4x squared plus 12x minus 72 equals 0. Remember, when you're factoring, the first thing you factor when asked to factor completely for anything is pull out the greatest common factor. Okay, so this is 4 times 1, 4 times 3, and then 4 times 18. All right, so the greatest common factor of all these terms is 4. So when I go to factor this thing, I can pull a 4 out first, and when I do that, what's left over would be x squared plus 3x, 4 times 3x would be 12x, and then minus 18, right? 4 times 18 would be 72 equals 0. Okay, so now I do have a product equal to 0. So I could apply the zero product property here, but I want to factor things completely. All right. So this is 4 still, that came out, and then the x squared plus 3x minus 18, this guy, would factor to x plus 6 times x minus 3. And you can double check, multiply these two, you're going to get x squared plus 3x minus 18 back. All right, so far, all my examples, I've ended up with a product with 2 factors. Here's a product with 3 factors. So let me just kind of extend the zero product property here. Even if I had 3 factors, or 4 factors, or 5 factors in my product, and it was a product equal to 0, then one of those has to be 0, right? So then, either A equals 0. So if I have A times B times C equals 0, then either A equals 0, or B equals 0, or C equals 0, or any combination of the 2 or 3 being 0. So we can still split it all up. Okay. So back in my equation here, I've got a product of 3 factors equal to 0. According to the zero product property, either the first factor is 0, or the second factor is 0, or the third factor is 0. Sorry, x minus 3 equals 0. Well, I'm not getting any information out of this, right? This can't happen. The 4 equals 0, So that doesn't give me any information. That doesn't give me any solutions. But the solutions are coming from the next two parts, right? So that can't happen. But or well, what if this happened? What if the x plus 6 was 0? Well, that's going to happen when x equals -6. Or well, what if these two didn't happen? What if this one happened? If x minus 3 was 0, well, that will happen when x is 3. And you check these. These are good solutions, right? And again, I'll do the 3 really quick, right? 3 squared is 9. 4 times 9 is 36. 12 times 3 is another 36. 36 plus 36 is 72. 72 minus 72 is 0. 3 does work. And you can do the same for -6. Check that out on your own. Right, so yeah, this one factor is never going to be 0, so it doesn't give me any solutions, but the ones with the variables in them, right, the factors with x in them, those are where I end up finding my solutions from. Alright, so I've got one last example of solving a quadratic equation by factoring. And I'm just going to keep it this way, with the negative. Again, I know I said I like having a negative coefficient, so if you want, you can add the 2x squared, subtract the 2x, but I'm going to keep it over there just to make one more little reminder for you. So I'm going to add the 12. Take it, put it in standard form. You got -2x squared plus 2x plus 12 equals 0. So now it's in standard form, right? Ax squared plus bx plus c equals 0. The greatest common, now I factor, right? Look at all, but first thing when you factor completely is look at the greatest common factor. The greatest common factor of all these terms is 2. But, and I think I've mentioned this in other videos several times, when the lead coefficient is negative, I'm going to not factor out the greatest common factor, but I'm going to factor out the opposite of the greatest common factor, right? So the greatest common factor is 2. I'm going to factor out -2. Right? So -2 comes out. And when -2 is removed, what's left over would be x squared, and then -2 times negative x would be positive 2x, and then -2 times -6 would be positive 12. Alright, so I factored it, but I haven't factored completely. Alright, we can break down this x squared minus x minus 6 more. So this is -2 times, and then x squared minus x minus 6 would factor to x minus 3 times x plus 2. You can check that, multiply these, you get this back. And then I have what I like, right? I have a product. Now there are 3 factors, but I have a product equal to 0. So applying this 0 product property, either the first factor is 0, but that can't happen. That's never going to happen. -2 is never going to be 0, so this doesn't give me any information. Or the second factor could be 0, x minus 3 could be 0, and this will happen when x is positive 3. Or that third factor could be 0, x plus 2 could be 0, and this will happen if x were ever -2. And you could check these guys, you'll see that they are indeed good solutions. Alright, I'll just check with 3 real fast. 3 squared is 9, -2 times 9 is -18. 2 times 3 is 6, so -18 plus 6 is -12. Yes, that works, and you can check on your own -2. Okay, so done plenty of examples here of when you're asked to solve an equation by factoring, you put it in standard form, right? Get every term to one side, 0 on the other. You try factoring that polynomial completely, and then apply the 0 product property, and of course check your solutions when you are done. And as always, I like to say, read the material beforehand, read through material, whether it be online or in a hard copy. Try to work through examples, understand examples on your own, maybe even read through the material once more, twice more. Make sure you try to understand things on your own first. I think it's more fulfilling that way. I think it sticks with you better. And don't just give up after the first attempts at some problems. If after several tries, 4 or 5, 6 times, you've read through the material a couple times, you're still not getting it, then it's no sign of weakness. It's not weak to go out and look for help after that. Find videos, ask a tutor, ask a teacher, ask a friend, but just stay persistent, keep at it. I know you'll eventually get it. and hopefully have fun with it as well. Thank you very much.